Hello and welcome to this lab on regression, including scatterplots and correlations. To get started, you're going to need to open SPSS with GSS 2018_time.sav, and we'll get started. So the first thing we're going to do is we're going to create a scatterplot. So we're going to click on Graphs, go down to Scatter/Dot, select Simple Scatter, and click on Define. Here, I'm going to make sure I display the variable names by right-clicking in the variable window here and selecting Display Variable Names. Next, I am going to follow the instructions listed in the Lab 7 regression instructions, and I'm going to put hours 1 into the y-axis, and I'm going to put education into the x-axis. Then I'm going to click OK. So now I get some output here, and we have a scatter plot. So this is what your scatter plot should look like. We should have the number of hours worked last week on the y-axis and the highest year of school completed on the x-axis. Next, let's add a best fit line. So we're going to double click on the graph here, and that'll open a chart editor. So here's our chart editor right here. And we're going to go to Elements, and we want to fit line at total. So that we're going to click on Fit Line at Total. We'll get another window that looks like this. This looks fine to me. We want a linear line. We're not trying to fit a quadratic or anything like that. And so we're going to just make sure that we have all of those things correct. We can change the color if we want, etc. So we're just going to close that. And we're going to go ahead and close the chart editor here. And we should see a line. So here's our line. Notice that SPSS also gives us the formula for this line. So the formula for this line is y equal 39.98 plus 0.1x. And what that's saying is that the prediction for how many hours you worked last week is going to be equal to about 40, right? 39.98 plus 0.1 hours per week for every year of school you've completed. So if you completed 10 years of school, in theory, you're going to work 39.98 hours per week plus an additional hour. 0.1 times 10 is 1. All right, so let's move on to part 2 of our instructions here, which is to create a correlation matrix. All right, so to do the correlation matrix, we're going to go to Analyze, Correlate, Bivariate. So again, that's Analyze, Correlate, Bivariate. We're going to click on Display Variable Names, and we're going to move hours 1, hours relaxed, and education into our variables window, and click OK. So again, here are our results. SPSS color codes these a little bit from positive to negative, but they also have the values here. So what these indicate is that there is, for example here, a slight positive correlation between the number of hours worked last week and your highest year of school completed, similar to what we saw in the scatter plot earlier. There is a slight negative correlation between the number of hours of worked last week and the hours per day you have to relax. Makes sense, right? The more you work, perhaps the less time you have to relax each day. And so that's what each of these numbers mean. A negative number means there's a negative relationship there. A positive number means there's a positive number here. So again, here are hours relaxed per day. There's a slight negative between the highest year of school completed and a stronger negative between hours relaxed per day and number of hours worked last week, which again makes some logical sense. So that's how we do a correlation matrix. All right, next we're going to create a dichotomous or dummy variable, basically a variable that is coded 0 or 1 with two different values of the same variable. So we're going to do that with sex. So we're going to go to transform. We're going to create dummy variables. So again, transform, create dummy variables. Again, I'm going to click display variable names. I'm going to move sex over to the create dummy variables for window. And I want to enter a root name here. So I'm going to type in d_sex. And this is basically saying I want the general name for this dummy variable to be a dummy for sex here. And we're going to go ahead and click OK. So that should be done now. And we can kind of see here if we scroll down on our variables window. So I went from the data view to the variable view here. You can see that we have a d_sex_1, and that's a dummy variable for male, and d_sex_2, which is a dummy variable for female. And typically what this means when it says it's a dummy variable for, say, female or male, is that sex equal female, that means female is going to be coded as 1 and male is going to be coded as 0. And we can double check this to make sure that we understand what is happening here by going to Analyze, Descriptive Statistics, Frequencies. And what I want to do here is put sex and our dummy variables in here, just to make sure that I'm correct in my interpretation and I have transformed these variables correctly. So I'm going to click OK here. And here we go. So here's our information for sex, our frequency table for sex. We see that we have 1,052 males and 1,296 females. So that means when we go to our dummy variable for females, which is this d_sex_2, I should see that, yes, 1 is equal to 1,296, so this 1 is female, and this 0 is 1,052, so the 0 is male. And we can see that for the dummy_1, where sex is equal to male, we have those flipped, where 0 is 1,296 and 1 is 1,052. So it appears we've successfully created our dummy variables here. So next, we're going to do bivariate regression. So first I'm going to go to Analyze. I'm going to select Regression, and I'm going to select Linear. So again, Analyze, Regression, Linear. Display variable names. And I'm going to use hours relaxed as the dependent variable, and my independent variable is going to be age. So I've put hours relaxed into my dependent and age into my independent. And I'm going to click OK. So here we go. So let's talk a little bit about how we interpret this and how we understand this. So here is our R-square. R-square is a measure of improvement, shall we say. How much have we improved our prediction by using that dependent variable? It's also called a proportional reduction in error. And in this case, we have improved our prediction of our independent variable, which is hours per day that the respondent has to relax. We've improved our prediction of the number of hours our respondent has to relax each day by 0.3%. Not a lot, 0.3%, by having information about their age. So it does not seem, at least based on this R-squared, that knowing the age of a respondent really helps us predict how many hours per day that a respondent has to relax. So that's what this is saying, and we're going to be focusing here on this R-square of 0.003. Next, we have the regression information. That's down here, and that's the next thing I want to focus on here. Is we have our constant. This is also our y-intercept of 3.299. So this means if our respondent is 0 years old, so right, this hypothetical respondent that is just born, In theory, they have 3.299 hours to relax each day. It seems a bit suspect, but let's move on. And then, for each year of age that the respondent has, their number of hours to relax each day increases by 0.01. So again, for each year of age our respondent has, the number of hours they have to relax each day increases by 0.01. So again, not a lot, right? We're talking, if we were to think about this in terms of seconds, each year of age would increase the hours you have to relax, or in fact, let's say seconds you have to relax, by 36 seconds per year of age. So again, not a huge impact here. We're talking you get an extra 36 seconds on average. Not a lot. All right, let's try a different independent variable here. Again, we're going to go to Analyze, Regression, Linear. We're going to take out age, and we're going to add in our dummy variable for female. If you've decided to rename this, you might have a different name for it, but we know that D_sex_2 is female. So we're going to click OK. Okay, so let's take a look at this one. Our R-square is a little better. Now, by knowing the gender of our respondent, we can improve our prediction by 0.7%. So again, not a lot, but more than before. So knowing the gender of our respondent improves our prediction by 0.7%. We can go down here to our coefficients. We see that our constant here is 3.970. This means, right, because we're now in a dummy variable where 0 is male, 1 is female, this constant here indicates the number of hours that men have to relax each day. And then when we add in females, right, when we include females instead, right, so this is an either or, men have 3.97 hours to relax, women are going to have 3.97 minus 0.474. So women have almost, not quite, and half an hour less to relax each day on average as compared to men, right? Women have about 3.5, whereas men have about 3.9 hours to relax each day. All right, finally, we're going to talk about a slightly different way of recoding variables, this time focusing on race. We want to make a dummy variable of race, but let's first take a look at what race as a variable looks like here. So we're going to go to Analyze, Descriptive Statistics, Frequency. We're going to remove these. We don't need them anymore. And we're going to add in race. So when we look at race, we can see that we have 3 categories. So making a dummy variable using what we did for sex here would create 3 dummy variables, one for white, one for black, and one for other. Our instructions here want us to lump black and other together as a non-white category and white as one category. And our instructions say we want black or other to be the 1 and white to be the 0. So let's go ahead and talk about how we're going to do that. So first thing we're going to do is we're going to go to Transform. We're going to talk about recoding into different variables. We're going to move race over here. We're going to put in a new variable name. I'm going to put this as non-white. That's going to be our variable name. And I'm going to select Change. You can label it here. I'm going to say this is a dummy for non-white. Make sure that is clear for me in case I come back to this later. And then I'm going to select old and new values. So the old value that I want to change first is going to be the non-white category. So I'm going to select range. And because black and other are labeled as 2 and 3 in our data, I know this because I know how space is coded, but you could also go look at the race variable and see how it's coded in race. I know that black is 2 and other is 3. And we want to combine those together, remember, to create that non-white category. So I'm going to combine 2 and 3 together, and I'm going to label this as 1. So that's our first category. Our second category is going to be white. We want to label that as 0. So I know that white is coded as 1 in this data, so I'm going to put in a 1 here for the value, and the new value is going to be 0. All right, so I think I've done it correctly. What I'm going to do is I'm going to hit continue and OK. And now we have that new non-white variable here. As always, it's really useful to go and check to make sure you've done this correctly. So I'm going to go to Analyze, Descriptive Statistics, Frequencies, and I'm going to add in my non-white variable here. I can get rid of my race, and I'm going to hit OK. And what we're looking for here is we want 0 here, right? Remember, this is our recoding of white. We want our 0 here to be equal to 1,693. And that looks correct. So 1,693 people in our original variable were white, and that appears to be the same here. That's a good start. Next, we want to check to see if these two were correctly combined. So if we add, and I'll grab my calculator here so you can see it. If we add 385 plus 270, we get 655. And indeed, when we look at our new dummy variable that we created, we see that 1, which again was our coding for non-white, is indeed equal to 655. All right, so that's everything you'll need to know how to do for your lab activity assignment. So you should be good to go for that. Thank you for watching. Have a good day.